Good morning, children. In previous class, we have learned about the spherical lenses and also the image formation by spherical lenses. And in order to track the image formed by a spherical lens, we need to consider three ray diagrams. And today, in this video, we are going to describe the image formed by spherical lenses when the object is kept at various positions. And first, we are going to see the image formed by the convex lens when the object is kept at different places. First, let us see a convex lens. Okay, and optical center, then here principal focus, the first principal focus and the second principal focus, 2F, of a lens. Here, assume that the object is at infinity. So, the light rays coming from the infinite object will be almost parallel to the principal axis of the convex lens. So, the incident rays are almost parallel to the principal axis. So, as we know that when the incident rays are parallel to the principal axis, after the refraction, these rays will converge at a point on the principal axis called principal focus. So what will happen? All these incident rays will converge at this point. And the converging point where the image is formed. And as we know that, so these all rays are refracted to a particular point, then this is the point where image is formed. So what will be the size, nature of the image? Since all these rays are converged at a point, the size of the image will be point. It's a point sized image. Point sized image. And what about the position? The position of the image is at focus. And what is its nature? Since the image is formed another side of the lens, so the image will be real. It's a real image. If the real image is real, then the image will be inverted. That means a real image will be always inverted in nature. So this is the nature, the position, the nature of the image formed by a convex lens when the object is kept at infinity. It's a point-sized image, is formed at focus, it's real and inverted. And since it is a point-sized image, then it will be highly diminished. Next, when the object is kept beyond 2F, see, consider another convex lens, optical center, F, 2F, here F, 2F. Now, here the object is kept where? Beyond 2F. Okay, that is the position of the object. Then, in order to track the image formed by this convex lens when the object is kept beyond 2F, first we need to consider a ray diagram, as I said yesterday. a ray of light which is parallel to the principal axis, and we choose a particular point on the object and top of the object which is parallel to the principal axis. So this is the direction of the incident ray. So this a ray of light which is parallel to the principal axis, then the lens will refract the ray, and what will happen to the refracted ray? The refracted ray will pass through the principal focus of the lens. Then another ray of light we are going to consider is from the same point. The first ray is considered. From the same point, another ray of light which is passing through the optical center of the lens. If any ray of light that is passing through the optical center of the lens, it will not refracted, so it will continue its path, okay, straight. So there is no refraction will take place. So you can see this is the point where these two rays intersect each other, and this is the point will be the image is formed. Since these two rays originated from the same point, and that point will be where at this point of intersection. So that means the top, okay, it will be here only, and it will start from the height of the image, start from where? Principal axis. So now if you observe this image form, the image is formed where? In between F and 2F. What about that is the position of the image? What is the nature of the image? The image is here inverted, right? Here it is upright and here it is inverted. So since the image is inverted, it is a real image. And what about the size of the image? The size is less than the size of the object. Okay? We compare the size of this object and image, and the size of the image is less, that means diminished. So the image formed by a convex lens when the object is kept beyond F to F, the image is formed in between F and 2F, and is a real and inverted image, and size is diminished. Now consider the object is kept at 2F. Okay, where is the object kept? At 2F. Exactly the same. The same way, here first we are going to consider a ray of light, incident ray of light that is coming from the object that is parallel to the principal axis. So that is the first ray, always we consider incident ray. And we know that the lens will refract the ray. After the refraction, the ray will pass through the principal focus of the lens. From the same point, a ray of light that is passing through the optical center of the lens. This is the point of intersection where the image will be formed. Okay, and if you draw these lines are straight, then the image will be formed where, okay, exactly on 2F of the another side of the lens. Okay, so where is the image is formed? At 2F. Okay, and what about the size and nature of the image? It's a inverted image and also formed on the other side of the lens, so it is a real image. And what about the size of the image? Size of the image is exactly same size of the object. These are the nature, position and the image formed by a convex lens when the object is kept at 2F. So when it is kept at 2F, and the image is also formed at 2f only, and the size are equal, exactly same. Next, another O principal axis, here 2f, here 2f. Now we are going to place the object in between f and 2f. This is the position of the object. Okay. Now consider a ray of light that is parallel to the principal axis. As we already know, this path will pass through the principal focus after refraction. And now we are going to consider another ray of light from the same point of the object that is passing through the optical center of the lens. Now it will pass without any deviation while it is passing through the lens. And this is the point of intersection where these two, where the image is formed. Okay, since we start from the two rays originate from the same point, and at the point of intersection also the same position will come for the image. So here we compare the object and image. You know that where is the image is formed? It is formed beyond 2f. When the object is kept in between f and 2f, the image is formed beyond 2f. What about its nature? It is inverted image and also found on the next side of the lens. So it is a real image. And what about the size of the image? The size of the image is larger than the object. That means the size is enlarged. The image is enlarged. Next, when the object is kept at f, so lens, optical center O, here 2f, here 2f. Now the position of the object is where? At f. So the first ray is an ray, it is parallel to the principal axis. It will refract through the point f on another side of the lens, that is passing through the optical center of the lens. So without any refraction, it will pass through the lens. Here you can see these two lines are parallel each other. That means these two lines are never going to intersect at any point. If these two rays are intersect each other, then that is the point where normally the image is formed. But here these two rays are not going to intersect at any point. Since they are parallel to each other, then the image will be formed where? At infinity. Okay. So where is the position of the image? At infinity. That is the position of the image at infinity. And what about the size of the image? Since the image is formed at infinity, its size will be highly enlarged. Okay. Highly enlarged. And what about the nature? It will be real and inverted. Since the image is formed on another side of the lens, it will be a real image, and if it is a real image, then it will be inverted. Another case, now the position of the object is in between f and the optical center of the lens. This is the position of the object. Consider a ray of light that is parallel to the principal axis. Then after the refraction, it will pass through the point F. Now another ray of light that we are going to consider is passing through the optical center of the lens. Here these two refracted rays, they are moved away from each other. Okay, they are not parallel, they are moved away from each other. So therefore they are not going to intersect at a point, so they are not going to form a real image of the object. Then where we will get the image then? If we extend these two rays back in backward direction, so this one and this refracted ray in the backward direction, and these two rays are refracted rays are appears to meet at a point on the same side of the lens. Okay, here this is the point where they appears to intersect, and this is the point where the image is formed. And here you see where the image is formed at the same side of the lens. Since the image is formed at the same size of the lens, since the image is formed at the same side of the lens, this is not a real image, it is a virtual image. And also we know that it's a virtual image. Why? Because the image is not inverted. Okay, so it is formed at the same side of the lens, and also it is not inverted. So we conclude that it is a virtual image. And formed at the same side of the lens. And what about the size? The size of the image is enlarged. Okay. So a convex lens is formed, a virtual image, when the object is kept in between the principal focus and the optical center of the lens.